Graphing piecewise functions. Okay, so let's graph this thing. So first let's graph this piece, negative x. So really, you can think of negative x as y equals negative x. And if you want to help you even more, you can think of this as having a plus 0 after it. Just to show that this is really in slope-intercept form, like y equals mx plus b. So with that, we can actually go over here and graph. We know that the y-intercept is 0, so we're going to start on the y-axis at 0. From there, we know the slope is negative 1, so we're going to go down 1 to the right 1, down 1 to the right 1, and so on, and so on, and so on. But we can also go in the other direction, doing everything opposite. So in other words, going up 1, left 1, up 1, left 1, and again, so on and so on, so we can get a better line. And we should get something that looks sort of like this. I'm graphing right now in this pink color. Okay, well this graph is good. This is negative x, but there's something else here. This graph should only exist when x is less than or equal to 4. So where is x equal to 4? So let me draw this vertical dotted line that goes through x equals 4. And this helps me visualize that everything to the left of this dotted line are all going to have x values in their ordered pairs that are less than 4. Everything to the right is going to have x values that are greater than 4 in their ordered pairs. So because I want less than 4, I only want things to the left of this dotted line. So we'll erase this dotted line because it was just there to help for a second. But then we can also erase everything in this pink line that is having x values greater than 4. So stop right there. Now, because it is less than or equal to 4, we will actually include this value, and I'll do it in pink. We'll include this value, and to do so, we have a filled-in circle or disk to signify that we are actually including this value. Now let's graph the other piece, the 1/2 x minus 2. Again, let's think of this like y equals 1/2 x minus 2. So that helps us visualize that's in slope-intercept form. So our y-intercept here is negative 2, and our slope is 1 over 2. So we're going to go up 1 to the right 2 to find a new point, up 1 to the right 2, up 1 to the right 2, so on and so on. And we also can go in the other direction, go down 1 to left 2, and so on. Okay, so let's put a line through these points. And so it looks something like this. Okay, so we've graphed 1/2 x minus 2. But we do want to keep in mind that this should only exist for x values greater than 4. So again, we can put this little dotted line to help us out. And x values that are greater than 4 are going to be to the right of this dotted line. Values like 5, 6, etc. So I don't really need this anymore. It was just there to illustrate what's going on. But let's erase all the x values on 1/2 x minus 2 that are less than 4, like these here. And keep on going. Cool. And get rid of these points as well. Now, do I want to include 4? In this case, I don't want to include 4 because x is strictly greater than. So there's a symbol that we use to show that we're just being strictly greater than, which is an open circle. And that lets me know that, hey, this value right here isn't really part of the graph. Okay, so let's find the domain and range of this piecewise function. So domain is going to be all the possible x values this graph represents. So if we keep going to the left forever and ever and ever, we'll get any negative value possible. We can keep moving, and there'll be a bunch of different points on this line forever, and we can keep extending this on and on and on for any negative x value. So every negative x value is covered by this graph, and then you keep coming back from there, and you're coming back and you negative 10, negative 9, etc. You keep checking all these x values, and you keep coming along, and then eventually this pink graph ends right here. So far we know that our domain goes from negative infinity to, well, right now it looks like it's ending at 4, but although the pink graph ends at 4, it gets picked up by the purple one right here. So now that the purple one picks it up, it fills in the hole. It continues on. 4 is good, 5 is good, 6 is good, 7, 8, 9, 10, etc. And it's going to go on forever as well. So all real numbers is one way to write this. You can write it as negative infinity to infinity, just saying that all those values are good. Any one of those kind of explanations are completely fine for domain. Now let's look at range. Range is a little bit more interesting in this case because range is the y values that are possible. The lowest y value seems to be right at -4. So we start at -4, and we're going to actually include -4. So when we use interval notation, we're including a value, we use a bracket. So bracket -4 means include -4, and we keep going up, checking a bunch of different y values. We check y values, yeah, all these values, good, good, good. Now, this new purple graph comes along, but that doesn't really change things. We're just checking if there's y values. And I keep going up. I can go up forever on this y-axis, and I will keep having y values on the graph somewhere. So that means that this goes all the way to infinity. Or another way you could write it as x, or y rather, is greater than or equal to -4.